Morning. Your camera working, Austin? And you'll have to, okay, you'll have to shut YouTube. You have to turn it mute YouTube, okay? You're pretty quiet too, so you have to get your camera working.
Is that there? Is this?
It's still quiet.
Yeah, you're so quiet too.
Just turn your camera on and your mic is on already. I think once your camera goes on, then you should be fine. Morning, Brooke. Same with you if you want to turn your camera on. Can you guys see me?
Yeah.
Okay. Okay, you work at getting set up. I'm just going to write a few things on the board to get ready to go here. Okay, I did this morning live with the grade 10s and it worked far, far better. So I'm recording it live on YouTube, but at the same time I had them on as a meeting, and this is going to work a lot better, I think, for us. Okay. All right. Oh, Eli, you're late by an hour. Okay, so we're multiplying and dividing rational expressions. So basically what we're talking about is multiplying or dividing. If I were to multiply this, I could multiply it straight across and get 24 over 44. That's a simple way of doing it. Hi, Tessa. So yeah, Tessa, if you're listening on YouTube, just mute the YouTube.
Yeah, Tessa, if you're listening on YouTube, mute the YouTube. Okay. Mute the YouTube.
There you go. No more feedback. Perfect. Thanks. Okay. So the other thing I can do, and this is what I would suggest, especially because this is how we're going to do it with polynomials, is cancel top and bottom first. All right. So that would be 8 divided by 4. That is then 12 over, oh, there should be a 2 here. Sorry. 2 here. What did I do wrong? No. Ugh. Tough day. Got off to a rough start this morning and it hasn't. 4 over 1. There we go. No, 2 over 1. 6 over 11. Yay. Finally, the easy part. Anyways, so what I'm doing is I'm canceling top and the bottom to do this. So when we multiply polynomials, that's the easiest way to do it. So open up to page 242. And I'll go through the examples on 242. So I've got 5 over 9 times 3 over 10. Okay, so again, you can multiply across the top and then multiply across the bottom, but then you're going to have to reduce the fraction anyway. So what I choose to do is I choose to reduce it even earlier. So right here, that's 1 over 2. That's 1 over 3. Now I multiply, and I end up with 1/6. So what we're doing, all we're doing is we're trying to multiply and divide expressions, okay? And when I multiply and divide the expressions, I cancel out to make them simpler, all right? So I'm going to do this question again, except I'm going to flip this and divide it just so that we have some practice with it. So I have 9 over 5 divided by 3 over 10. So when I divide fractions, I have to multiply by the reciprocal of the second fraction, like that. And then I would cancel out again. 1, 3, 1, 2, and that would give me 6. So just remember that when you're dividing fractions, that you flip the fraction and then you multiply by the reciprocal. All right. Okay. So those are the easy guys. Now let's look at a polynomial expression. So I've got x plus 1 over. And when I'm writing these out, I'm instantly factoring. I want to get these things to lowest terms as quickly as possible. So the bottom one's going to factor, bracket, x and x, okay? And then I have minus 3 minus x minus 2, bracket, x and x, and then I have plus 4 plus 1. Okay, so the very first thing that I do is I factor out all of my expressions. Then my non-permissible values are my restrictions. So x can't equal 3, x can't equal 2, x can't equal -4, x can't equal -1. So 3, 2, -4, -1. Now that I have my restrictions done, I want to simplify. So again, approach it as if it is just fractions. Anything you have on the top, you cancel with anything you have on the bottom. X plus 1 cancels with x plus 1. X minus 2 cancels with x minus 2. I'm left with 1 over x minus 3, x plus 4, and then write in my restrictions after. Okay. So the most complicated thing that will arise in this is just your restrictions, because you're going to have to, especially when you're dividing, you have to use both sides of it, Brooke, right? Okay. So we just keep practicing it. Okay. And probably 90% of the time, you're going to have something on the top and something on the bottom that cancels out. Very rarely will you not have that. All right. Now I can move a little slower too. Now that you guys are on live, if I'm going quickly, because the pace, I just go with how I feel. So if you need to slow down or want me to slow down, just let me know. All right. So working example 2, all it wants is its non-permissible values. So I've got AB squared C squared D divided by E minus 2 F add 1 G H minus 6. All right. So what we are looking at in this is, first things first, what can the variables not equal? So I look at my denominators, all right, and I start with them. Well, I see that C can't equal 0. Makes sense, can't be a 0 down there. D can't equal 0. That would be an undefined value. G can't equal 0. H can't equal 6, right? Okay. Now that takes care of all my denominators, but we have another issue here, because when I go to actually solve this, I have to flip this fraction, right? I have to flip that fraction. So then that means that these are also denominators, and I also have values that they can't equal. So E can't equal 2, and f cannot equal -1. So this question was just designed so that you understand that there is more variables or more non-permissible values. Okay, so you just have to remember that when you're dividing, that the non-permissible values occur on the top and on the bottom of the fractions. All right. Dividing. Okay, so we just did some. We'll do all three on the working example. So 3/4. And again, because I'm dividing, times 2/9. I have to flip that fraction. You can see they do it right below that. And then again, my personal preference is to cancel. Again, you don't have to do that, but I like easy math. So that's why I choose to do it. All right, rather than going 6/36 and then trying to figure out the reduced fraction. Okay. B, x plus 3, x minus 3. Again, I'm going to flip it right away. So that gives me 4x. Sorry, maybe not. Let me do this different. I'll write out the actual question. So x and 4x minus 12. Okay? So at this point, I could find my non-permissible values. So I see that x can't equal 3. I know that one from this guy, right? This one here, I'd have 4x minus 12 can't equal 0. 4x can't equal 12. X can't equal 3. So it's the same one. And then I have to remember, because I have to flip this, that x also cannot equal 0 because I have to flip that fraction, right? So that's the first thing that I may do in this. And then at that point, I multiply by the reciprocal. I'm also going to factor this guy. Notice I took the greatest common factor out of 4x subtract 12. I took a 4 out of it. Okay? And now I simplify it. Those cancel. That leaves me to 4x plus 3 over x, where x can't equal 0 and 3. Okay? We're all right? Okay. All right, let's look at the last one then. X minus 7 times x over x plus 4. And again, this is the point where I start to shortcut, so if you don't like it, just let me know. But I'm going to reciprocate that second fraction. And I get x squared minus x minus 20 over x squared minus 2x minus 15. Okay, so factoring x and x. Oh. Not right now, Eli. Sorry. Okay, so while factoring, I took the factors of negative 20, negative 5, and 4, factors of negative 15, negative 5, and 3 to give me those two values right there. So I've got a list off now. Okay, I've got a list off here. X can't equal. All right. So first one is negative 4. 5, negative 4 again, and negative 3. So again, because I flipped this fraction, all of these have non-permissible values within them. Because if I, let's say right here, I put a 5 in, that's going to make this 0 down here. Doesn't work. All right, negative 4 doesn't work. So the only thing that we didn't have to work with was that x minus 7 because it's only a numerator. All right, so last thing we do, just simplify. Those cancel. Those cancel. And I'm left with x minus 7 over x plus 3. And then I write in my non-permissible values. Eli, I can't. All right. We okay? Yeah? No, I see my buddy joined on to my YouTube again. All right. Okay, so I'm done with the lesson part of it. Did you want to look at anything from yesterday's assignment?
Did you do 3D on page 235?
Hi, Morgan. Yeah. 3D?
Yeah, 3D.
Okay. Okay. So, it says factor fully. Remember to look for common factors first. So that's the same thing. I would look for greatest common factor. Okay. So when I'm doing it with variables, it has to be the variable that has the smallest exponent on it. So for example, I have a squared and I have a, right? I can only take an a out of both of them. I can't take an a squared out of an a, but I can take an a. Just 1 second. Sorry. All right, Eli, hold on. One sec. I'm sorry, you're gonna get. Okay, sorry about that. All right, so to factor this, I'm going to take an A out and a B out. Okay, so A, B. When I take an A out of A squared, I'm left with A. When I take a B out of B, I'm left with 1. Subtract. I take an A out of A, I'm left with 1. And a B out of B cubed, I'm left with B squared. Okay, so far? Okay. You can leave your volume on there, Morgan, until I'm done, just so I make sure you got this right. Okay, so looking at the bottom then, at the value of 5 and 25, what would you take out of there? 5. Just like that, that's right. And then an A out of both of those. Then I can also take a B out. All right, now here's the catch. I take a 5 out, an A out, and a B out. Most people don't write anything in there, but I have to write this in there. I have to write a 1 in there because I am dividing it. So it's 5AB divided by 5AB, which leaves me with 1. Okay, and then I take the 5 out of here. That leaves me with 5. A, and that's it. So that's as simplified as I can get in terms of my factoring. So far, so good?
Yeah.
Okay. And it says, all right, so it says state any non-permissible values. Well, when I look at the bottom here, A can't be 0, B can't be 0, so I can get that figured out. And then here's the catch. I have 1 plus 5A can equal 0. So 5A can equal -1. A can equal -1 over 5. So A also can equal -1 over 5. So that's a tricky one right here looking at that. Okay. And then to simplify this, AB divided by AB leaves me with that, and that's what you're left with. So the answer would be A minus B squared over 5 times 1 plus 5A, and then A can equal 0, -1 over 5, and B. Okay? All right. Good. Did you have any other ones, Morgan?
4B on page 236.
Okay. 4B 236. X squared plus 5x minus 6. X squared plus 6x. All right. Okay. So factor the top part first. X, X, and factors of -6 would be plus 6 and -1. Okay? Now, what's the very first thing that I always tell you to look for when it comes to factoring? Greatest common factor. What can I take out of x squared plus 6x? X. And that's going to leave me with x plus 6. Okay? All right. So my non-permissible values are 0 and -6. Like that. Okay. I'm left with x minus 1 over x. X can equal 0, -6.
Okay, that makes a lot more
Okay.
sense. I was just stuck on those two, but that makes a lot more sense now.
Okay, perfect. All right, and I suspect the factoring will cause a little bit of problem still.
Yeah.
Okay, if it's only 2 terms, you're looking for a greatest common factor, unless it's difference of squares. That's usually where the mistakes get made, is right there. You forget that I can take one value out of both of them.
Yeah, that's what I was getting confused with when it was that it was 2 on the bottom. But
Right.
That makes more sense now with the greatest common factor.
Okay, perfect. All right, do you have any other ones?
No, so they don't need to.
Okay,
I have a question.
sure, go ahead.
You just did this one with Morgan, like 3D, and I did it earlier, and I thought I got it, and
Yeah.
I got the same answer in the back because they just had a minus b squared over 5 plus 25a.
Yeah.
I just kind of wondered, what did you do to get like the brackets like 5 minus 1 or something?
No, okay, so this is what I have as my answer.
Is it still the same?
Yes,
Okay.
it is. I don't understand why, if you're trying to factor in the lowest terms and you can take a greatest common factor out, I don't understand why you would leave it as 5 plus 25a. I know the book does that, but to me, that's not making any sense. Like if I'm trying to break this all the way down and I can factor at any point, so I would factor out that 5. To me, this is the right answer here, Amron, but it isn't wrong.
And what for that answer? You just have a minus b squared 1 plus 5a.
Sorry, I'm just going to turn the volume up here. Oh, there we go. This is all on me. Okay, say that again, Amron.
What do you have as the answer? I can't really see it. It's just you have a minus b squared over 1 plus 5a?
Yeah. Yeah.
Okay.
Like can you see up here? It says 5ab plus 25ab squared, or a squared b. I take a 5 out of there and ab out of there as well. And so that leaves me with 1 plus and then 5a.
And then I have 3c on 335?
Yeah.
Or 235?
Yeah.
I don't know how to do that one.
Okay, so like I just said to Morgan, if you only have 2 terms, okay, you're looking for a greatest common factor. So I have 10x squared plus 70x. Is there a type of, just out of curiosity, is there a marker color that works better for you guys to see than what I'm using?
I don't think so.
Like, does blue better, black better? Does it matter?
Red's good right now, whatever you're using.
Okay.
Yeah.
Okay. All right. So looking at the top then, Amron, I need to take out some. So what can I take out between 10 and 70?
I thought you could take it like 10x.
Okay.
But you can't, can you?
Sure you can. Absolutely. So then what are you left with?
Just x and 7?
Right.
X
So
plus 7?
x plus 7. That's absolutely right. Okay. Perfect. Okay. And then what about on the bottom then?
5x.
Okay. And if I take a 5x out of there, what am I left with there?
X plus 5.
X plus
1.
1. Right? Because 5x divided by 5x would leave me with 1. Correct?
Pardon?
I said 5x
5x.
divided by 5x leaves me with a 1 there. Okay?
Yeah.
So I have 10x times x plus 7 on top and 5x times x plus 1 on the bottom, right?
Mm-hmm.
Okay, and now I'm going to divide 10x by 5x, and that's going to leave me with just 2. So I have 2x plus 7 over x plus 1, and that would be my stated answer, and my non-permissibles would be 0 and negative 1. Did the book leave it as 2x plus 14 on top?
Yeah, that's why I was wondering, do you have to like distribute it?
No.
Like I got that too, and I clicked the button.
Yeah, no, Amron, I wouldn't do that. To me, this is what I want to see in your final answer all the time. I want it broken right down to the bare minimums if you can.
Okay.
Okay. Any others, Amron?
I don't think so.
Okay. Anybody else on here?
I have a question.
Yeah.
Page 236, 480.
H?
Yes.
Okay.
Thank you.
Okay, so factoring wise, the top one, we can't take out a greatest common factor. So I have to, the long way to do it would be to do this. Product is negative 9, sum, negative 8, factors, negative 9 and 1, right? Okay, so I'm just going to rewrite this on a different board. So I have 3x squared minus 8x minus 3. Okay, and I've got 3x squared minus 9x plus 1x, oops, subtract 3, put my brackets in there, 3x, take that out, that's going to leave me at x minus 3 plus 1 times x minus 3. So to factor it, the top part would factor to 3x plus 1 times x minus 3. So I'm going to put that over here. So I'll make sure I got that right. No, sorry, signs are wrong. Okay, so there's what I have on the top part, Austin. And then the bottom part, I'm going to take out a 3. So that's going to leave me at x squared minus 5x plus 6, right? If I factor the 3 out first. And then I'm going to get x minus 3, x minus 2. Okay, from this. So the factors of plus 6 are minus 3 and minus 2 that add to give me a negative 5, right?
Yeah.
Okay, so far so good?
Yeah.
All right, my non-permissibles, 3 and 2. And then I simplify. Like that.
Okay.
All right? Okay.
Thank you.
No worries. Anybody else have questions? Okay. So my only question / comment now would be, is this the best way we've approached this so far to do these lessons? Do we like this approach better?
Yeah, this is a lot better.
Okay. I like it too. I like being that it has more of a classroom feel. I can feel more interactive with you. And again, it'll still be on YouTube. So you can go back and watch it if you need to as well. So I think it kind of works well for everything. Okay? If you don't have any more, then we'll sign off here. And tomorrow we'll do the same thing. We'll come back on in the morning at around 10:15, somewhere in there. I'll put the post on Edmodo, but if you're watching between 10 and 10:15, I'll be on live, okay? Okay, everybody have a good day. We'll talk tomorrow.
Okay.
And get your assignments in. Get your assignments in if your name's not on that board. Okay, talk to you later. Bye.
Okay. Bye.
I'm going to call Eli now.